Okay, and we're on to the second revision video for the C1 topic. Today we're going to be looking at combustion and the products of the two different types of combustion. A little bit of a recap. So in the first video we talked about hydrocarbons, and we explained that hydrocarbons are very simply just hydrogen and carbon bonded together by covalent bonds. So a simple example of a hydrocarbon would be methane, which is CH4, which means it has got a single carbon and it has got 4 hydrogens. If you were going to draw its chemical structure, you would have a carbon. Carbons always make 4 covalent bonds, and then you would have the hydrogens around the outside, 1, 2, 3, and 4. So the rules here, we've got carbon, which makes 4 covalent bonds, hydrogens, which make a single covalent bond, and that's how they would bond together. Each of the fossil fuels are hydrocarbons, which means they only contain hydrogen and carbon. Different hydrocarbons have got different numbers of carbon and hydrogen, which means they have different chain lengths. Now, the use we have for fossil fuels is basically we do a chemical reaction called combustion, which is where a fuel substance reacts with oxygen to release useful energy, usually in the form of heat. There are 2 different types of combustion. You can have complete combustion and you can have incomplete combustion. Which type of combustion happens depends on the amount of oxygen available in the environment around that combustion reaction. If there is enough oxygen, if there's a plentiful supply, then we get complete combustion taking place. If there is a limited supply of oxygen, then we get incomplete combustion taking place. So we can look at complete combustion first. Complete combustion is where you get a hydrocarbon, so the example could be methane, so CH4, combines with oxygen, and you get carbon dioxide produced as a waste gas, and you also get water being produced. Now, to just balance up that equation, we need to double the amount of water, and we also need to double the amount of oxygen to make sure it's all balanced together. Now, you can identify complete combustion by the products that it creates. It obviously creates energy as a byproduct, it also creates carbon dioxide, and it creates water. Now, to make sure that you know that you are carrying out complete combustion, you need to be able to have a test for carbon dioxide, and you need to have a test for water. Now, test for carbon dioxide is you use lime water, you bubble the gas produced through the lime water, and if it goes milky, that's a positive reaction, and that shows you that there has been carbon dioxide produced. If you want to test for water, then you use a substance called cobalt chloride on a special paper, which in a condition where there is no water present will be a blue colour. As soon as water is present, it will change to being a pink colour. So if you set up an experiment like the one we've got at the bottom here, you carry out combustion, which means you just have a Bunsen burner going. If the air hole is open, it's getting an awful lot of oxygen, which means it will carry out complete combustion. If the air hole is closed, it's got a limited supply of combustion, and you'll get a yellow flame, and that means that it's incomplete combustion. So if you set it up with a blue flame, you know you're doing complete combustion. The 2 products of combustion will flow up this pipe here. The first thing is they'll come into this chamber here where cobalt chloride paper is. It will detect the water, and this cobalt chloride will turn from a blue colour into a pink colour. The products then continue through the next delivery tube down here, and there they will bubble through a liquid, which is lime water. When you see the bubbles, obviously you can tell there is a gas being produced, and when the lime water goes from being a fairly clear solution into a milky solution, then you know that you have got carbon dioxide as a product there as well. This is just a little bit of a break, just a chance for you to pause the video and just think about what are the key points so far, what are you identifying, what is the main learning objective so far. Okay, the second type of combustion is, we said, was incomplete combustion, which is what takes place when there is a limited supply of oxygen. So again, you have a hydrocarbon, you have the oxygen, and this time the products are carbon monoxide, carbon, and then water again. So this time it's the carbon monoxide and the carbon that is the different products. Incomplete combustion is usually shown as having a yellow flame. It produces much less heat energy, and it also produces obviously carbon as a waste product, which means that anything you are heating using it can leave a kind of sooty deposit on the bottom of the object that you're heating. So incomplete combustion creates carbon as a waste product. It contains carbon monoxide as a waste product, and it also produces water as a waste product. Now, we've already talked about how you can test for water using blue cobalt chloride paper. Now, the second product is just carbon, small particles of carbon. We call that soot, and you can just detect that because it will build up on any surfaces that are being heated. The third product is carbon monoxide. It is a very, very poisonous gas. It is also completely colourless and it's completely odourless, which means it is very, very dangerous because you cannot smell it, you can't taste it, you cannot see it. You would not know it was leaking into your house. This is why houses now should have carbon monoxide detectors in there, because most houses now have boilers in them that heat their water. These boilers carry out combustion on a daily basis, 24 hours a day. The boiler is always lit. If there is a problem with the oxygen supply, it will change from doing complete combustion to doing incomplete combustion, which means it will produce carbon monoxide as a waste gas. If that builds up, it can be very, very dangerous to anyone who's living in that house, because it will build up and they will start breathing it and they'll become poisoned. This is why it's very, very important that you have all of your appliances in your house tested regularly to make sure that there is no incomplete combustion taking place, there is no carbon monoxide being released. So I think we'll have this time has been a bit of a recap. So what we want you to do is, if you can just pause the video, you can have a look at this slide and then we can see what you can fill in. Can you identify the colour of the flame when it is complete combustion? Can you identify the colour of the flame when it's incomplete combustion? Can you identify the amount of soot made in both examples? Can you identify the amount of energy produced, so relatively, basically, which one produces more? And also, can you identify the products made in both different types of combustion, and you can explain how you would test for each one of these products. So if you want to pause the video now and have a go at that, please. Okay, and then the last part of this video, I need to look at decisions that you would have to make when you are choosing a fuel. So basically there's 7 main factors that you would want to consider when you are deciding what fuel are you going to use when you are heating your house. And then you've got your options of the 3 different types of fossil fuel. You've got your coal, you've got your fuel oil, and you've got your natural gas. So the first thing you need to think about is availability. So basically, how easy is it to get? How easy is it for that to be supplied to your house? Coal, obviously, can be delivered in a big bag. Fuel oil, you can deliver it in a tanker. You can have it stored outside your house. And then natural gas, it needs to be piped in, so you need to be attached to the mains. Second thing is you need to think about how much does it cost, how expensive is it. Again, you can see there, coal is relatively cheap. The other 2 a little bit more expensive. The energy value just means how much energy does it release per unit that you are going to burn. So if you compare a kilogram of coal, fuel oil and natural gas, how much energy would that 1 kilogram of that release? Coal releases a medium amount, it's alright. The other 2, a little bit more energy, so you're getting more heat energy for your unit. You might also want to consider the pollution. So does it affect greenhouse effect? Does it affect acid rain? Is it going to be affecting climate change? And then again, coal is the most polluting, and then the other 2 medium levels. What I think is quite an important one is ease of use. How easy is it to use? Natural gas, you turn on your hob and you do a single spark and it's ready to cook on. Your boiler uses it on a daily basis, it's not a problem. Again, fuel oil, very, very simple to use. Coal, you have to be able to light your own fire. You can't have it come on at a specific time. It's much more difficult to use. Next one, how toxic it is, how poisonous it is. Coal, it's not that dangerous. You can handle it with your bare hands. As long as you wash your hands afterwards, it's absolutely fine. Fuel oil, you know, it can have health effects. I wouldn't want to be touching it with your bare hands. And then natural gas, very, very low, not dangerous in pretty much any way, except for the fact that it is a flammable gas. Last thing to think about is your storage. How easy is it to store? Obviously, coal, very, very easy. Put it in a sack, leave it outside. Fuel oil, again, very, very easy to store. You just have a tanker outside. You have a big bottle, basically, to fill it up with. Natural gas is much more difficult to store. Generally, you have to be attached to the mains to get it delivered. Now, I know there's an awful lot of information there that I've given to you in a very, very short period of time. However, This is the kind of thing that they will ask you a 6-mark question on. They will ask you to explain and describe what different fuels could you use and why would you choose a certain fuel, and you need to be able to explain what different factors would you be thinking about while you are choosing a fuel to use in your home.